Hi everyone, we're getting very close to the end of the year and we just have this video and one more and then we'll be finished. So let's get to it. So we're going to be talking about logarithms today. So logarithms is a concept that you studied last year in Algebra 2, but it's been probably a year or more since you've seen it and you've likely forgotten what it's all about. And it's very important because it's going to come up again in your future math classes. So some of you have told me you're going to take either AP Calculus or Honors Calculus next year. Well, logarithms is something that will definitely appear in both of those classes. Now, some of you told me that you plan to take either Honor Stats or AP Stats. And again, logarithms are a part of that too. So this is something that no matter what math course you're taking, you will definitely see this again. And I just want to make sure that you're prepared. Okay, so let's get to it. So in our last video, we discussed the exponential function. So it had the form y equals b to the x power. So the b was the base and the variable x was part of the exponent, so it was called exponential. So every function has an inverse, including this one, and the way that you were taught in the past to find an inverse of a function is to switch the x and the y. So in this case it would be x equals b to the y. And then you would solve for y. Well, in order to solve when the variable you want to solve for is in the exponent, you have to use what is called a logarithm. So you will see an equation of this form. It will be y equals log base b of x. So notice that it has the same numbers, x, b, and y, as the previous one, but they're rearranged. So again, this is exponential form, and then this is logarithmic form. So the base of the exponential form becomes the base of the logarithm. The x, the number that it's equal to, is the number that you're going to take the log of, and the exponent becomes the answer. So that will be the case in all of these examples. Now there is one little rule, is that the number x, whatever you're going to take the log of, that number has to be greater than 0. So you cannot take the logarithm of 0, nor can you do a negative number. And we'll get back to that at another time, and later in the video, I mean. Okay, so there are two special types of logs that you will encounter. So one of them is called a common log, and it has a base of 10. So if you were to see a logarithm, and all it has is just log x or log whatever number, and you don't see a subscript like the base over here, then that will be a 10. So you would never ever seen it like this, log base 10 of x. Even though it's true, you will never see it in that form. What you will see is this. So if you ever see a log that does not have a little base, a subscript, that means the base is 10. Another special log is called a natural logarithm, and it's abbreviated ln. So it would look something like this, ln x, that's an L, not an I. And it stands for a natural logarithm. So you might be wondering, well, why isn't it NL instead of LN? Well, it has to do with Latin, and I know some of you take Latin. The word for it is Logarithmus naturali. So it's L first, then N. So if you wanted to know, that's what it is. But in math, we use natural log as LN. Now what it means is that the base of the log is e. So you will never see it written log base e of x like that. Even though it's true that e is the base, that's not how you write it. It will always be written like this. So these are the special logs. There's going to be the common log with a base of 10, the natural log with a base of e, or it might be a log that actually has a number here in the base position. Okay, so we're going to go ahead and do some examples now. Let me erase this. So let's go on to number 1. Okay, so in number 1, notice that you have some equations that are right now in exponential form, and you are changing them to logarithmic form. Okay, so let's look at 1a. So the equation is 3 to the 4th power equals 81. Okay, so that's called exponential. You are going to switch that to logarithmic. So you're going to look at the forms that I showed you, which are still on the top of your note sheet. So you're going to write a logarithm, it's abbreviated log. The base of the log is going to be the same thing as the base of the exponential function. So it's going to be base 3. The number you're going to take the log of is the 81. And the answer will be the exponent, which is 4. So it looks like that. And when you read this, you say log base 3 of 81 equals 4. So these mean the same thing, but this is called exponential form, and this is called logarithmic form. Okay, so let's take a look at b. b is 10 raised to the 4th power is 10,000. Okay, so that's an equation in exponential form, and we want to change it to logarithmic form. Okay, so you use a log, that's the abbreviation for logarithm, and the base of the log will be the same thing as the base of the exponential function. So the 10 will be the base of this log. Now, just a minute ago, I told you that you would never write the 10. So don't write any base for that. That's understood that it will be 10. 10,000 is the number that you're taking the log of. And then the answer would be the exponent 4. So there it is. Log of 10,000 equals 4. It's understood that the base is 10 if nothing is written. Okay, and there's one more in this section. E raised to the 0 power is 1. So we've discussed E in the previous lesson for exponentials. E is called the Euler number or the natural base E, and it's a number approximately equal to 2.71828 and so on. It continues indefinitely and does not repeat. That's called an irrational number. But that's actually the number, E, 2.71828. So you learned in algebra that if you ever raise a number other than 0 to the 0 power, you get the answer 1. So this follows that same rule. So if you have to change this to a logarithm with a base of E is called a natural logarithm, and it's abbreviated LN. It's understood that the base is E. Do not write log base E. So it would be the logarithm of the number 1, natural logarithm of 1, will equal the exponent 0. So that's how you would rewrite it. It would be the natural log of 1 is 0. Okay, so that takes care of number 1, changing an exponential equation to a logarithmic equation. Now in number 2, we have to do just the opposite. We're going to start with a log equation, and we will change it to exponential. So the equation that you see is log base 2 of 32 equals 5. Okay. So we're going to change this to exponential. So whatever the base of the log is will also be the base of the exponential. So that would be 2. Whatever the answer is, which is 5, that will be the exponent. And then the 32 will be what goes after the equal sign. So it will be 2 raised to the 5th power is 32. Okay, so for B, we have log of 1,000,000 equals 6. So log of 1,000,000 equals 6. But we want to change that to exponential. So notice there is no base written. So if there is no base, that is considered to be 10. So use a base of 10. The answer 6 would be the exponent. And then after the equal sign, you would put 1,000,000. So 10 raised to the 6th power is 1,000,000. That would be part B. And then one more for C. The question says natural log of E equals 1. Okay, when you see a natural log, the base of the natural log is E. So you would write E raised to the power of this number, 1, will equal this number, E. So you have E to the 1st power equals E. Okay, so that completes number 2, changing the log equation to exponential. Okay, so far all we've done is switch back and forth between one and the other, and that's important. You will see it again in future math classes, but the next part of it is really what the meat of logs is about. So let's go to, sorry, this is number 3A. So the directions say that we're going to evaluate these logarithms without a calculator. Okay, so this is something that you really need to know. I'm not just joking you. It will come up again in calculus and in stats as well. Okay, so let's look at how we would go about this. So what we're going to do is, even though it doesn't look like an equation, you can always say that that is equal to a variable, say x. And you can change it to exponential form. So you would have the base being a 2, raised to the x power is the answer 16. And you would have to figure out what power of 2 would give you 16. So without a calculator, you just have to kind of think about multiplying by 2's. So if you did 2 times 2, that would be 4. If you did 4 times 2, that would be 8. And if you did 8 times 2, that would be 16. So that means you multiplied by 2 4 times. So the answer would be 4, because 2 raised to the 4th power is 16. Okay, for B, we have log base 7 of 49. And again, we have to figure this out without a calculator. So if you don't see an equation, you can always make one just by setting it equal to x. The base would be 7, raised to the x power is 49. So you want to think 7 to what power would be 49? That's an easy one. 7 squared is 49, so you would say the answer is 2. Okay, so for part C, we have log base 49 of 7. Now this one is not the same as B, because the 49 is the base and the 7 is the other number. So we would still think of it the same way and say 49 to the x power is 7. So this one is a little tricky because 49 is larger than 7. So what you would do without a calculator is you would think how 49 and 7 are related to each other. And hopefully you would recognize that 49, if you took the square root, that would be 7. So it would be like the square root of 49 is 7. Now in Algebra 2, you also studied what are called rational exponents, and you were taught that any radical can be rewritten as an exponent that is a fraction. So that's what you would do here. So 49, the square root of that would be the same thing as the half power. Now where the half comes from is that 49 is like 49 to the first power, that's the 1, and the 2 comes from the fact that it's a square root. Square root implies 2. So 49 to the half power would be 7. So your answer for part C would be a half. So anytime you see a square root, think of that as being raised to the half power. Okay, so D, we have log base 9 of a fraction 1 over 81. So we have to think 9 raised to what power will be 1 over 81. Well, how are 9 and 81 related? 1 over 81 would be the same thing as 1 over 9 squared. And also in algebra, you learned in your exponent study that if you have an exponent in the denominator of a fraction, that is a negative exponent. So that would be the same thing as saying 9 raised to the negative 2 power. Any negative exponent is in the denominator of a fraction. So your answer for part D would be negative 2. Okay, so that would be number 3A through D, and I'm going to erase this now, so stop the video if you need to catch up. For part E, we have the natural log of e to the 4th power. Okay, so if you were doing this without a calculator, like you should, set it equal to x, and you'd have to remember that a natural log has a base of e. So you would say e raised to the x power would be e to the 4th. So that's an easy one. Of course, x would have to be 4. F, the natural log of 1. So again, set it equal to x, and remember that the natural log has a base of e, raised to the x power is 1. So I mentioned this earlier in the lesson. Whenever you have a number other than 0 and you raise it to the 0 power, you will get 1. So raising it to the 0 power is what would happen here. Your answer would be 0 for part F. Okay, so for G, we have the log of 0.1. So without a calculator, you would need to change this decimal to a fraction, and you can do that by thinking of place value. So after the decimal point, that would be considered the tenths place. So that would be considered the same thing as log of 1/10. 0.1 is the same thing as 1/10. So any exponent that is in the denominator, like think of that as being a 10 to the first power, any exponent in the denominator can be rewritten as a negative exponent. So it would be the same thing as 10 raised to the negative 1. Sorry. 10 to the negative 1 power. Yeah, sorry. Okay, so now we have to finish our answer. So when you see no log with a base, it's 10. So you're trying to think 10 raised to what power would be 10 to the negative 1. So then your answer is just negative 1. Okay, and then h, we have a log with a base of 5, and it is cube root of 5. Okay, so what I mentioned in an earlier example is that any radical can be rewritten as an exponent. It's called a rational exponent. That means it's a fraction. So we could rewrite this one as 5 with an exponent that is a fraction. So think of the 5 as being like 5 to the first power. So that would be the numerator, and 3 would be the denominator since it's a cube root. So if you ever see a cube root, it's the same thing as the 1/3 power. So you would be trying to think, if you set this equal to x, 5 raised to what power would be 5 to the 1/3. So of course the answer would have to be 1/3. Okay, so that completes through h. So I'll have to erase that in just a minute. So go ahead and pause the video if you need to catch up. Okay, so then in I, in that section, we have log of 100. And we don't know what it is, so you can say it equals x. So without a base, we know that to be a 10. Raised to the x power is 100. So 10 to what power is 100? Well, 10 squared is 100, so that would have to be 2. So part I would be 2. Okay, so that's how you would work logarithms without a calculator, is that you would change each one of them to exponential form, and then you would try to figure out what the exponent would need to be. So the next part of the lesson, we're going to look at how you would evaluate with a calculator. So this is something that will come up too, because there are some of them that you will not be able to just figure out on your own. So I'll show you what I mean in just a sec. Okay, so what if we had number 4a? It says log base 4 of 39. Now the reason why we need a calculator for this one is you would not be able to figure out in your mind what power of 4 is going to give you 39, because it's not a whole number. Like 4 squared would be 16, 4 cubed would be 64, so it's got to be somewhere in between 2 and 3, but we don't know exactly. So the calculator will have to tell us. Okay, so I know some of you have a different style calculator than I do, so I'll have to show you differently how you would do this, but I'm talking right at the moment to people who have a calculator just like mine, like the TI 83, 84 plus, CE, and so on. So here's what you would do. You would go to math, which we have been in many times this year, and you want to arrow down, scroll down all the way to the bottom, even past all these numbers that you see. There's more things down there, and you might see this option that says log base. If you have that option, press enter. If you don't, I'll tell you what to do instead in just a minute. Okay, so you would need to put the 4 for the base and the 39 for the exponent. And I think I have too many parentheses here. Okay, so it should be just like that. Log base 4 of 39. Okay, so press enter and you should get this number. And if it's not a whole number, I'm going to say to round it to the thousandths place. So you would put down 2.643 as your answer for 4a. Now, if your calculator is different than mine and you don't have that log base option under math, you can use what is called the change of base formula, and it's pretty easy. It's just that you have to enter it differently. So the formula is on your paper, but here's how it would go. It's not hard at all. You're going to use the common log button, which is right beside number 7. That means log with a base of 10. You're going to put in 39, close the parentheses, and then put divide by common log again with a base of 4. Not 4, not base 4, log 10, base 4. Okay, so this is called the change of base formula. So when you do that, notice that you get exactly the same thing as what the rest of us got that have the calculator as mine, same as mine. So don't worry if your calculator is a little bit different, it'll still be okay. So use that instead. Okay, so I want you to not always just type things in the calculator. I want you to understand what you're doing. It's never ever a good thing in high level math to just punch things into a calculator and have no clue what's happening. You will not be able to do calculus or stats well if that's what you're doing. So let's remember what this means. When you ask the calculator to get this log, you're looking for the exponent that is needed to get the answer 39. Like what power of 4 will give you 39? So let's try it. I want you to see how this works. So take the base 4, raise it 2. Now I don't want to round that answer, nor do I want to put all those numbers in because that's still rounded. I want to use the answer button, which we've talked about in the past. It's with the negative sign. So what if you did 4 raised to the answer power? You would get 39. So it's saying that 4 raised to the previous answer gives us the answer 49. So that's what the calculator has figured out for you, is what exponent was needed there. Okay, so that would be 4a, 2.643, rounded to the thousandths place. Okay, so the next one is pretty similar. You would go to math, all the way down to the bottom, scroll down. So if you have that log base option, choose that. And you're gonna put in 5 for the base of the next one. And then over here, it will be 216. And press enter. Okay, so you should be getting this number, 3.3398, which would round to 3.340 if you did it to the thousandths place. Now, if your calculator didn't have that option, you would use the change of base formula, which would look like this: log of 216 divided by log of 5. And then your answer is exactly the same thing. So either way, you'll get the same answer. So what it means, be sure you understand this, is that if you took the number 5, raised it to that number, so use the answer button, you should get the original number, which was 216. Okay, so that's what you do if you see a base like in those like 4 or 5 or other numbers. Now for part C, notice it just says log 489. So that's understood to be a base of 10. These are really easy. You can just use the log button right beside number 7. That's the common log, base 10. So this one you can just put in log 489 and be done. That's it. So rounded, that would be 2.689 to the thousandths place. So what that means is if you took the number 10 and raised it to that power, because that base is 10, you would get the number you started with, which was 489. And lastly, the natural log is right beside number 4. It's ln. That's not an I, that's an L. So it's natural log of, our number is 167. So that's all you do is press that, and you get this answer. Rounded would be 5.1188 in the thousandths place. Now what that means is that a natural log has a base of e, so I would go to the e to the x button, put in that answer, and notice it would be the same thing, 167. Okay, so that's how you would work logs with the calculator. The calculator is helping you get the exponent that you need to raise that base to. Okay, so at the beginning of the lesson, I told you that you cannot take the logarithm of a negative number or 0. It says at the beginning of the lesson that that number x has to be greater than 0. Okay, so I want to show you what will happen if you try. Like if you did I'm on number 5 now, 5a, natural log of 0. Your calculator should give you an error domain, and it says value is not allowed. That is because the domain of x, the number you're taking the log of, has to be greater than 0. Not greater than or equal to, but greater than 0. So that's why that's happening. So you would write something like either not possible or undefined as your answer for 5a. Do not write error as your answer. Either say it's not possible or it's undefined. Okay. And that will be the same thing for these other ones. So if I were to quit out of that one, if I try the next one, it's natural log of -3. It's going to say something similar. This one says non-real answers, but still you're not going to write that. You'll say either it's not possible or it's undefined. Okay. And even for a common log, like the one right beside number 7, same thing, that's with the base of 10 though. If you try to do the log of 0, you'll find that the same thing happens. It says error domain, so you would say undefined or not possible. Another one is the log of -1/3. Still not possible. And one more. What if it was a logarithm with a base of -2? You would go to math and all the way to the bottom. Remember, you might have the log base option. And you would put -2 for this and 4 over here. And that's not possible. Okay. So anytime you see that error, you would either put either not possible or undefined, and that would be it. Okay, so that completes our study of logarithms for today. We're going to have one more lesson that I'll post soon, and that will be it. So I hope y'all are doing okay. Good luck on your AP exams. I know you have some soon, so hope it goes well for you, and take care. See you next time.